Hello, my name is Maria Canini, and today I will be presenting the research I've conducted for the past year. We investigated error-related negativity and how anxiety, depression, and ADHD may influence it. Error-related negativity is a response of the brain that appears when a mistake is made, and we were able to detect it using EEG technology, which allows us to detect electrical brain activity at the scalp and then plot it into waveforms. To do this, we collected data from 31 participants at ETSU. We investigated what the levels of their anxiety, depression, and ADHD may do to the ear and amplitude to see if the disorders may affect error processing. Previous research had found, in fact, that anxiety and depression may affect the ear and amplitude by increasing it, showing that people affected by these disorders may have a hyperactive error detection system, while people with ADHD have a much smaller ERN, suggesting that their error detection system may be deficient. Scholars have not investigated what the effect of the three disorders combined or being present simultaneously would do on the ERN, and that is what we investigated in my research. After recruiting the 31 participants, we had them come in for a study session. Participants were required to, first of all, fill out 3 self-assessment surveys in which we detected what their level of anxiety, depression, and ADHD was. Following the surveys, participants were asked to complete a flinker task, which consists of them indicating in which direction an arrow points. They're presented 5 arrows, and they all may point either to the right or to the left, or the central arrow may point in a different direction from the other 4. They were asked to only indicate in which direction the one in the middle was pointing. After this, we had all of the EEG data with their waveforms. We plotted them into a grained average, and we found the presence of an ERN for incorrect trials where participants had made mistakes, while there was no ERN when they were correct, indicating the direction of the arrow. After this, we also ran a multiple linear regression to see if the 3 disorders may have any influence or a significant influence on the ear and amplitude. Surprisingly, against what every other piece of literature I've read has said, there was no significant influence on the ear and amplitude. Well, why did we get these results, though? One main reason may be that although we used about a sample size that we used in previous studies, we were looking at 3 disorders together, so we may need to triple the sample size to see any sort of effect. We also may need to consider subtypes and mild versus severe cases.